Hello everybody and welcome back to Oxygen Not Included. Today we're going to be taking a look at Regolith melters. Regolith melters are usually a very late game build that you will make, if you make them at all. But they do something kind of unique, which is get rid of a lot of Regolith that you end up with in the game. And they generate material resources for you. And ultimately, as we're going to show today, they can generate a lot of power for you as well. So while they require a lot of very difficult construction methods, while they benefit from access to space materials, right? Even though there's a lot of difficulties presented in making a Regolith melter, conceptually they're not that difficult, and they do something that is really hard to recreate in any other sort of build. So let's get to it. The basic principle here is that we're going to be taking Regolith, this material that we harvest from the surface. It's deposited on the surface of the asteroid by various meteors and comets that impact it. We're going to get it around 300 degrees, and we are going to heat it up to its melting point of roughly 1,410 degrees Celsius, at which point it will turn into magma. Magma then can re-solidify into igneous rock, and then we can use that igneous rock to do various things. That's the basic idea of a Regolith melter, is having a way to get rid of a lot of Regolith and turn it into igneous rock, which can then either be fed to stone hatches to make coal, or crushed into sand to make glass, or just used as a construction material around your base. A lot of things you can do with igneous rock, very little that you can do with Regolith besides use it as a filtration medium. So the basic idea, pretty simple: heat the stuff up, and you're going to have a number of components in the system that are sort of necessary. Number one is going to be your heating element. This is going to be what takes the Regolith and puts it over that melting point. And so here we have a large thing of magma, and we have a thermosensor to detect when this area has cooled down too much, and we're going to then introduce thermal contact between this sort of heating pad, this heating element, and this source of magma. And that's going to keep this nice and toasty at the melting point of the Regolith. And then we have conveyor lines of Regolith coming in, ready to be melted, right? All the resulting magma is then dropping on the floor, at least with this design of a heating element. There are other designs you can make that'll do different things with the magma. You can, in fact, have your conveyor rails go through this magma area. Because I wanted to show sort of a scalable system, one that can handle multiple lines of conveyor rail. I don't have that sort of setup because it would be just sort of geometrically difficult to arrange, but you could have that, say, with a single line really easily, and cool down your magma in that same heating element, basically, right? Use your incoming line of Regolith to cool down the magma to its solidification point, at which point you can pick it up. So you can merge this component with another component if you have sort of small enough capacity, and I guess if you think about it hard enough, there's probably a way to have a large capacity, a scalable system that also has that feature. I didn't think of it, so this is what we have. But pretty simple, right? I have basically a radiator. It is having conveyor rail of Regolith brought through it. It is in contact with a hot area, and then I control the temperature with a simple thermosensor, right? We watch this go. Regolith is coming in. It's melting on its way here, right? If I go to the shipping overlay. Oh, the lag. There we go. If I go to the shipping overlay, it's going up here, but then about halfway through, it's melting, right? And that magma is just then depositing on the floor. With this design, I have the magma then traveling to a cooling pad, and on this cooling pad, it re-solidifies into igneous rock, and then it is sent off to the rest of the system. If you have your incoming Regolith cooling down the magma and solidifying it, then you don't really need a cooling pad. So again, these elements could kind of be combined together. But for a scalable system, I think this is pretty simple. And the cooling pad kind of starts to get at what we want anyways, at least with this build, which is power. This cooling pad pays for itself. We can use these steam turbines, and I've kind of built a lot of them to show you sort of how far you can reach, at least with just a couple layers of steel tile as your sort of conductor for this heat. But you can take that heat and power this whole system by itself. There's not a lot of moving parts here, right? I've got some auto sweepers, some conveyor loaders. The key thing, I guess, is to know that you're going to need to cool down these auto sweepers and conveyor loaders. So normally I'd have some sort of cooling line traveling through here. This is all vacuumed out area anyways, so I wouldn't need to worry too much about, thermal communication between that cooling line and this area. It's all sealed off. But if we put a little bit of petroleum on the ground here, right, underneath this auto sweeper here and underneath this auto sweeper and these conveyor loaders, then we can have a cooling line going through here, and it will be in thermal contact with these auto sweepers and loaders, even though there's a vacuum in this room, because of this little thin layer of petroleum. So you want to have like a cooled off area for moving this stuff around. Here I kind of have a two-stage moving process, right? There's one that overlooks the cooling pad itself, and the other one is managing all these different lines. Again, with a smaller system, like if you only had one line of Regolith coming in, you could manage this differently. You could merge this system in with this system. You could have the incoming line of Regolith be the thing that cools down the magma. But I like this system, scalable, and also I can control this thermosensor, which means when I'm doing the initial build in survival, I can crank this thermosensor all the way up. I can basically just say, continue heating this until it's really, really hot. And then the Regolith that comes in is going to be at 300 degrees, but this heating element is still going to be able to melt it because I've let it crank the temperature up so high. So having this sort of system is really robust in terms of building it in survival, because then you are able to control this temperature, right? It's more control over the system, and you're able to start it up by cranking up the temperature really high. That way it's able to melt colder Regolith as it comes in. I say relatively cold because Regolith naturally spawns at 300 degrees, so you're going to get it at a fairly high temperature, but we need to heat it all the way up to 1,410 degrees, and to aid in that process, basically every Regolith melter also has a heat exchanger. Here I've made it out of glass just so you can kind of see what's going on. I guess diamond window tile would also work as well, but I just have a counterflow heat exchanger here. Right here's a layer of diamond just to kind of show how efficient that is. And this igneous rock is going to preheat this Regolith that's coming in. This Regolith is now coming in at 1,345 on this line, and then because it's a little bit more efficient over here, 1,376. Right? If I had more conductive material, I could have this temperature come out basically right at the melting point of the Regolith if I wanted to, right? But we're going to take a lot of the heat that is necessary to heat up this Regolith, and we're just going to use this igneous rock that we have to perform that task. And one of the neat things is that Regolith has a specific heat capacity of 0.2, and igneous rock has a specific heat capacity of 1, just like magma, right? Which means that you're going to have a lot of heat left over in this igneous rock even after it's done heating up all this Regolith. So this Regolith is entering at 300 degrees, right? And it's coming out at, say, 1,300 degrees, a little bit more than that, 1,350 to 1,375. But the igneous rock that is then coming out, and I've separated out these lines, so here's my incoming Regolith, and here's my igneous rock. This igneous rock is coming out as still like 1,100 to 1,200 degrees, depending upon kind of where it was in the system, right? Like this is the colder end of the heating element because this is glass and isn't very conductive, isn't a very conductive material, right? You could use like a refined metal if you wanted to, if you kind of were willing to spend the money on that instead of the glass to have a better and smaller heat exchanger. I haven't gone for smaller because I have my Regolith lines going all the way from the top to the bottom, so I have a lot of space to work with. I have basically the entire length of the map. So you can have just a system like this, bunch of glass panes with a conveyor rail traveling through them as your heat exchanger. That works perfectly fine, right? This system works exactly fine with even just glass as the material. Right, more conductive materials better, allows you to make something smaller, but smaller isn't necessarily something that you need in the build. And yeah, so the igneous rock is coming out very hot. Now, in the past, what a lot of people do is they then go ahead and just feed that hot igneous rock to hatches, stone hatches, and make coal out of it. Because the stone hatches don't really care about the temperature of the igneous rock, and they're going to produce their coal at a fixed temperature. So this is a good way to just delete a lot of that heat if you want to. The trick, though, is that you need to have a ranch that doesn't have a lot of thermal communication with that igneous rock. Either it's in vacuum of some sort, or you have some other mechanism going on to prevent this hot igneous rock from heating up the ranch and killing the hatches. But that's not terribly difficult to do because hatches are pretty resilient creatures and they can survive in a lot of conditions. So you basically just have them sitting in a vacuum if you like. But here we've decided to go a different route. which is that we're going to harvest all that sort of thermal energy, or a lot of it at least. And here I've again used glass, when a more conductive material would be better. But just to sort of illustrate the idea so it's see-through and transparent, we have our regolith lines traveling up here and then exiting out here. And I have a nice little vacuum seal, which is preventing any sort of heat from getting out of the system. I'd want to have cooling lines go and cool down these steam turbines, right? So I could have dedicated cooling lines sort of along here, but they don't need to thermally interact with this. This is all vacuumed out. One nice thing also from having it go all the way up to space is that the vacuum construction techniques that you want to use, right? This entire area needs to be in vacuum because you don't want thermal communication between it and the other areas. That whole process is a lot simpler once you have this area exposed to space, because you can just kind of dig this out and then wait a while, and eventually all of the stuff will release to space, right? That this will vacuum itself out for you without you having to build any pumps and figure out where anything goes, right? And since that's where you're harvesting the regolith anyways, here I'm just kind of cheating, and I have a bunch of regolith being loaded up into these conveyor loaders. But normally you would have some sort of regolith harvesting system covering more or less the entire span of your asteroid, right? But in any case, exposure to space can aid in that building process in survival and make it easier to have this area all be vacuum sealed and this area be vacuum sealed and so on and so forth, right? You can basically build a lot of the stuff and then just expose it to space and wait, come back 100 cycles later when it's all vacuumed itself out, right? And start building everything. But I've shown off a few various methods for how you can do your heat exchange. One is you have a gas shutoff line, right, running hydrogen gas through some sort of hot area into the area that you want to heat up with your steam turbines, right? And basically you can set that to a thermosensor and say, look, if the temperature is above a certain amount, then I want you to shut off, right? Keep in mind that there's only really so much thermal mass you can carry in one of these radiant gas pipes, right? Hydrogen with some sort of temperature difference is only going to support some amount of heat in order to keep these steam turbines going. So you'll want to calculate out for however many steam turbines you have going, how much you'd want to use that system. Another one that's very simple is you simply have a door, right? And this door can control whether or not the system is in thermal contact with whatever your hot line is. Another one, of course, is you just take your regolith and you run it directly through whatever you want your heating element to be, right? And so you can have this, right now I just have the regolith kind of going straight up and then it drops down. You can have the regolith kind of U-turn or its way through these little nooks and crannies that you've packed with steam turbines. That's another way to accomplish that sort of system. But either way, there's a lot of thermal energy to harvest in this system, right? Because this is a fairly high specific heat capacity. I mean, relatively speaking, right? 1 is decent, and it's at a temperature of around 1100 degrees when it comes out here, right? 1100, 1200 degrees, and you can cool that all the way down to basically 200 degrees on steam turbines. Getting a really efficient system like that would probably require a lot of refined metal and whatnot. But so one answer, as opposed to just feeding these lines, like you could have it go through this heat exchanger, and then you take these lines and you just feed them into ranches, right? These, instead of being steam turbines, would just be hatch ranches, and probably not this many of them, because you don't need that much to feed hatches anyways. But instead of that, you could use that to power your base, right? This is a lot of systems all sort of connected together. Right, here's where I would have transformers spoking off to various other systems, right? Here's the battery that connects to this one, and then there's a battery that connects to this one. And if you run sort of the calculations, for every single line of regolith that you have coming in, right, this is 20 kilograms of regolith that, absent the mass duplication bug, which is basically a problem where when solids melt, sometimes they double themselves. Absent that, which hopefully will be patched when the game releases, you're going to have 20 kilograms of igneous rock coming out, and 20 kilograms of igneous rock with a specific heat capacity of 1, right, and a temperature difference of around 1,000. You might not be able to get all of that temperature out. I mean, here I'm not getting everything out, right? Like I have a bunch of stuff at around 600 degrees. But even if I'm only getting half of it out, right, even if I'm only getting, I mean, half I guess is a difficult term to use there. But if I'm going from, say, 1,200 to 600, right, that's 600 degrees at a specific heat capacity of 1, so 600 times 20,000 right, DTUs per line that I have going through here. That's a decent amount of thermal energy. You can power a lot of steam turbines with that system. I recommend, if you go with this method, have a system that has a really high thermal mass. A really, really high thermal mass. That way, even if you don't have regolith coming in for a while, because it might be that you process your regolith in batches, right, because there's only meteor showers so often, have it so that it will still keep on producing power for a good amount of time, right? The more thermal mass you put in the system, the longer it's going to take to boot up, but the more consistently the system is going to run once you've got it going, right? Even if this regolith line gets interrupted, even if something breaks, your power system won't break because you have a lot of stuff in your system that's all been heated up to 300 degrees or something, and you can kind of just sit back on that and coast on that as your stuff starts to cool down, right? You have a long period of time to fix things if they break, or just get more regolith if you're in between regolith showers, right? So let's discuss some various changes that you can make to these elements. Again, the heating element and the cooling pad can be merged if you have a small enough line, or you just have a really clever way of doing the geometry, because you can use the incoming regolith to cool down the magma and solidify it. And basically, the version of that would be, just imagine that this heating you have this one heating element right here, and then you have it like right next to here. So you have the regolith instead traveling sort of around down this area and then up, right? So it dips into this area before it goes up, and then you have your auto sweeper able to sweep up sort of that same area there. That'd be sort of an idea for merging these systems. Another thing that you can do is, if the magma is in an inconvenient location, right? You don't have a volcano and it's really down, deep in the magma area wherever you want to build the system. What you can do is use your regolith to increase the amount of magma that you have, right? We're turning regolith into magma anyways. Once you've got these regolith lines built, you can actually just have them dump straight out into the magma, and the magma will increase and increase and increase. And if you've built sort of the channel that you wanted to go in beforehand, right? So I could have built these pipes beforehand, I could have built these temp shift plates, I could have built a lot of this stuff beforehand, and then just dumped a bunch of regolith in until eventually the magma rose up to that point, right? And then I can build my system around that. So you can pre-build an area, right? And then dig out exposure to magma, start dumping regolith in, get that whole area filled up with magma, and then start running your system. So that's one option that you have. You can create more magma very easily as part of your building process, because that's basically what you're doing with this build anyways. Another option, of course, is that if you don't want this to span the entire length of the map, because that is a pretty big project, right? You can, instead of using magma, use molten glass from glass forges, right? And you can basically have a little thermal sensor that says you have some sort of heating element here or some sort of heat source. You put a bunch of molten glass into the system, and then whenever the temperature starts getting a little bit low, you run these glass forges some more, and the system can basically be self-powering then. You can keep on adding more heat to the system using these glass forges, as long as you kind of keep them in vacuum. That way that you don't have to worry too much about this pipe, or you just run this pipe through sort of insulated tile, right? Whatever this output pipe for these glass forges is should be protected from cooling down, and just at least to some extent. In any case, you can build your entire system out of molten glass and then put it anywhere, right? It doesn't have to be at the bottom of the map if that's the case. And the nice thing is that this system generates tons and tons and tons and tons and tons of igneous rock, which can then just be broken up into sand and fed into your glass forges. So you have the ability to create all the things that you need to do the build with the build. There's a little bit of a chicken and the egg sort of thing going on, like how do you get the glass in the first place? But reheating your system is going to be really easy once you've got this build online, because you've got all this igneous rock to turn into sand to then turn into glass. Likewise, you are, depending upon how you design this heating element and how efficient this heat exchanger is, right? If this heat exchanger is perfectly efficient, then you don't need to sort of refill your heating element at all. But over time, slowly, your heat source will start to cool down, right? I think this heat source started around like 1650, 1670, and now we've got it down to like 1600, right? So eventually what's going to happen is that this thermal sensor is going to keep this area active longer and longer and longer, until eventually we don't have enough sort of heat going in to keep the system running. The answer to that, again, same thing, glass forges work really well. You don't if you don't build your system out of glass, you can still reheat it with glass really easily because, again, you're getting a huge supply of igneous rock through this process, which you can turn into sand. And basically, same idea, thermosensor. If this is sufficiently cold, then I want you to turn these buildings on. You just have these queuing up molten glass infinitely, right? So whenever the system gets sufficiently cold, you'll output molten glass at a temperature of, I think, like 2,000 degrees Celsius. It'll travel through here. It'll exchange heat with the system, dump all its heat, and then you can have it just exit out into some area where it can be cooled, right? Because you don't really have too much of a use for it anymore. It could just be something like, you know, you put it on your cooling pad, for example. You could have this loop back around to your cooling pad area and have this using the glass as well, right? You could basically have a system where your reheating method, if that's relevant for your system, if your heat exchanger has some inefficiencies in it, you can take that reheating system and just have it dump out onto the same area as your cooling pad and allow this to transport glass as well as igneous rock. And then you would have some supply of relatively cool glass ending up over here, right? Something along those lines. That's if you want to use this sort of reheating system, or if you're fine just kind of having this stuff progressively get cooled down, cool down, cool down. So yeah, that's one option. But I think the reheating system is going to be most relevant when your heat exchanger is kind of bad, which I guess is the case for this build because we're using just normal window tile, like normal glass, not diamond or anything like that, no refined metals, right? We're just using some basic stuff. So the heating, the heat exchanger is not really that great. This isn't coming out at 1400 degrees Celsius. It's coming out a little bit lower, and the additional heat has to be supplied by the system. But if you have a really efficient heat exchanger and you're not using molten glass as your sort of your hot stuff, right? If you're choosing to use a build that is at the bottom of the map, then you probably want to be having this reheating system going on at some point in time. Other things to note. The way the system is set up right now, it can be self-powering with these steam turbines. But again, if this is a really efficient heat exchanger, then you're not going to have a lot of need for this cooling pad here. Like this cooling pad is not going to absorb much heat before it cools down this stuff, right? Because this magma is not going to be at 1450 degrees Celsius. It's going to be pretty much right on the money at like 1410. And as a consequence, you're not going to, right? The igneous rock is immediately going to solidify and then be moved off somewhere else. So having the system self-powering does kind of rely on you getting a little bit of heat out of the system, and that heat is then going into powering these steam turbines. If you don't want to have, you know, the necessity of reheating your system with some glass forges, then you're probably also going to need to figure out a different powering method for the system, right? It's not going to be self-powered anymore. It's going to be something else. So, you know, there's a bunch of trade-offs in terms of how much heat you're drawing from the system, which allows you to either generate more power or do other things. There's trade-offs sort of with the scalability of the system because some geometries of heat exchanger are a lot easier to do when you only have like one line going in as opposed to 4 or 10 or whatever. Yeah, this heat source can just be molten glass that you've accumulated in an area. That can make things really simpler for where you place things, right? And make it simpler in the sense that because you can place them anywhere and build anywhere, that you have a lot of ability to kind of control your building environment. You don't have random geysers around the place, or anti-entropy thermal nullifiers or points of interest kind of cluttering things up. You just have one, clean area to work with because you've decided on where you want to work with. In any case, there's a bunch of trade-offs there with whether or not you're using magma or glass forges. But magma also has the simplicity of you just go down to the magma biome, and even if the magma isn't in a super convenient location, like it didn't spawn in a way that you like, you can just dump more regolith in to make more magma and continue on that way. You do need a cooling system ultimately for these conveyor loaders and auto sweepers down here. That's probably one of the tricky things that I think trips a lot of people up because you want to have this room vacuumed out. That way you don't have parts melting and stuff. Right, but you also want to have these sort of moving parts in here. The solution is something like this, right? You have these sort of elevated off the ground and have a little bit of petroleum down here. That way they can work. You can also stick pumps, air pumps down here to make sure this maintains a vacuum. Although I think really you just want to design your system so that it doesn't break in the first place rather than have a bunch of pumps to try and recover from that. because it's just going to be tricky. You're not going to be able to pump out everything in time. This is a very difficult survival build, again, because of this need for all this vacuum stuff. But other than that, I think it's very doable, right? It's just the size and the sort of the stakes are very high, right? Because the temperature is very high. In terms of what sort of space materials you need, you don't technically need any space materials to make this build work. I'm just using a lot of steel for a lot of these things. There are a lot of points where you can use wolframite or tungsten really easily because that also has a really high melting point. You can use things like obsidian to great effect. So, for example, a lot of these temp shift plates are made out of obsidian. Basically, for a lot of these components, you're just going to want something with a high melting point. That way it doesn't melt your system. But even something like glass is workable, right? Because glass actually melts at a higher temperature, right? 1426. Melts at a higher temperature than the igneous rock. So the igneous rock that's coming in here is never going to be at a higher temperature than that. So you have a strict cap on what that temperature is going to be. And then once things have left the heat exchanger, then you have a little bit more flexibility because this is coming out at around like 1150 degrees Celsius. And so you can begin working past this heat exchanger point with materials with a lower melting point. But I guess the real trick is insulation. I have built all of this entirely out of insulation, right? Just to for demonstration purposes. In practice, you would probably want a lot of this to be ceramic, or normal tile would actually work fine, but you'd want this to be ceramic, and then at like corners like these, you'd want to have your insulation. I've sort of worked to make sure that I have, like for example, this entire heat area around here, this is a vacuumed out area, right, where I want to work with this igneous rock, and I have basically the beginnings of an airlock here. This all wants to be vacuumed area because these gas shutoffs have an overheat temperature of 75 degrees, so I don't want them getting heated up. I want to be able to drop this whole thing down, right? So I basically have a vacuum seal around this entire build. I've got vacuum on top. I've got vacuum on this side. I guess I have contact with this here just because I have this awkward thing here. But you'd have space as your vacuum above. You'd have this vacuumed line over here, right? And then when we get to the bottom of this whole system that I have down here, I have another vacuumed room for processing this into sand. Right, and I can have a layer of vacuum right here. I could have like an ore dropper type thing to drop the sand down all the way, you know, over to here, where then it gets transported to my glass forges or something like that. Right, so you can have like a vacuum seal across this entire thing, and that'll minimize the degree to which you need to use any insulation, right? Because the vacuum will be a perfect insulator anyways. And it's really just going to come down to things like, I don't want, if this was ceramic, I'd have some heat transfer going across this line, right? I could then either just have a break here, right? I could like say don't have this tile here, right? And then in that case, maybe the only sort of point of insulation I need is at some corner right here or right here, right? Basically where you just don't want a line of ceramic connecting to the system. Also in areas where you have direct exposure to the magma, you might have some difficulties because I believe ceramic has, what is ceramic's melting point? Let's go ahead and slap down some ceramic here. Okay, the melting point, whoops, that didn't work. Insulated tile, ceramic. Okay. Ceramic has a melting point of 1,849 degrees. So depending upon how you set up your heat source, if it's hotter than that for some reason, right? If there's any sort of heat generation that you have going on in here, you need to worry a little bit about your ceramic melting. In practice though, right, your magma biome is all spawning at around like 1650, 1670. Your glass forges aren't going to get things that hot, so the melting point of ceramic is not super relevant. Just something to keep in mind depending upon how you design your heating system, right? The ceramic will melt at a point that is not that far off from where we're at, right? It's sufficiently far off that you usually don't need to worry about it, but you might need to worry about it. Just keep that in mind. So I think that's sort of the coverage of the entire system. Again, just to kind of show the shipping, pretty simple. We have lines of regolith coming in. They are melting. The magma is then flowing to a cooling pad. That is then cooling it down to igneous rock where it's loaded into these other lines. I split the lines, right, kind of braid them together. I have a counterflow heat exchanger to preheat this regolith to really hot. That way I don't have much strain on my heating element, right? The regolith line can be from wherever, right? This is just going down from the surface. But then my igneous rock line can then travel either to a bunch of heating elements, which are used to power steam turbines, or it could just be dumped directly into a chamber full of hatches, and the hatches can eat that. So long as that chamber is sort of vacuumed out and the hatches aren't being boiled by the igneous rock. They're fine eating hot igneous rock. Or alternatively, you can do neither. You can just pound it into sand and then take that sand and ship it back down to your glass forges and use the glass forges to make glass, which will reheat your heating source and also provide you an infinitely renewable supply of glass. Lots of things you can do with this system. I've gone the route, and I'm titled the video one where you can basically power your entire base. And I'm not joking. I mean, this is just so much thermal energy. Your challenge is just going to be having enough materials to efficiently extract all this, right? Having the refined metals and whatnot at a sufficiently high melting point to just have a bunch of heating elements, right, out of this sort of finned design. If all these were refined metals, it'd be a very expensive build. But the amount of power that you can get out is absolutely huge, in particular because of the bug that I think is still active, where sometimes you'll get twice as much magma out as you will put in regolith. It's not 100%, but that happens sometimes. So, this build might need to be tweaked in the future to account for that. Right now, it's kind of been designed assuming the bug is not going to be present in the final version, but even if it is, the system still works just fine. So, yeah, I think I have covered pretty much everything and a lot of your design choices that you can make in the system. In future videos, I might cover what a sort of regolith surface harvester might look like, how you would design that. I guess one other thing to note, depending upon how your sort of regolith system works, you can obviously just do away with a lot of these conveyor rails and just have like an ore dropper, right? So one other thing that you could do is you could just, instead of having these conveyor rails go all the way down from the surface, which is a lot of, iron or whatever material you're using to build these conveyor rails, pretty much everything works because this is only a 300-degree system. You can use like lead or whatever. Actually, can you use, what is the material? Just a second. Shipping, conveyor rail. Okay, you can't use lead, but any material, copper, something like that will work fine. But instead of just having these kind of go by conveyor rail down here, you could just have them all just dropped, right? So I could have conveyor chutes just like right here, and then I could have another conveyor loader slash auto sweeper set up down here, way back down here, in order to load things back up onto the lines, right? So this can also be changed, but just a general idea. A view of the ventilation. Again, I just have hydrogen loops going in here just to demonstrate one idea for how you would extract heat from your regolith lines. The door system, right? There's a lot of automation that you can do. You can automate these doors. You can automate this heat transfer system. You can automate these steam turbines. All these are options for you. Yeah, okay. I think the video's gone on long enough. This is a pretty sufficient system, I think, and a lot of different choices you can make on how you design it, depending upon scalability versus convenience of only having one line to work with, and et cetera, et cetera, et cetera, different heating elements, different everything. I think I've covered everything. Okay, that's it for the episode, and I'll catch you guys next time.